maybe introduce Dennis for those who don't know him. He's a cosmetic chemist at Colonial Chemical, and you are one of the smartest guys that I know on surfactants. So I thought that you would be a good person to drill on the topic for this
Or,
webinar. You know a lot about surfactants, so maybe the first question
yeah,
is.
I've been using surfactants poorly for a long time.
So maybe my first question is, what is a surfactant?
Yeah, so the word surfactant is like a concatenation of surface active agent. So I don't know. I usually tell people that it makes water wetter. It basically helps the interface, between water usually and some other substance like an oil or a silicone or dirt or what have you. So it helps you to achieve cleansing and foaming a lot of times in formulations, although it's not necessarily restricted to that. So things like emulsifiers are also surfactants, but a lot of times people will talk about surfactants just as like kind of the foaming agents in cleansers. But they really serve a lot of different functions in formulation, helping to um, get that emulsion or solubilize things into fragrances, like for example into water, or to provide that cleansing and foam, things like that.
And then with that, what are the different types of surfactants out there? And maybe it would make sense to split them up in charge, and how do those work together? And then also
Right,
you've kind of alluded to like solubilizers or emulsifiers, surfactants,
right,
so on.
yeah, yeah. So we usually, yeah, and that's exactly right. Kind of divide surfactants into four major types by charge. So anionic surfactants, which are negatively charged, are usually the detergent surfactants. Um, they're typically designed for at least personal care to have relatively high foaming properties, um, also to provide that cleansing and to be able to interact with other surfactants in the system to get things like the viscosity and foam profile that consumers are looking for. Now, there are, of course, anionic surfactants that can serve other um, functions as well. So, some things like phosphate esters are used a lot as emulsifiers. So, you see a lot of times like cetyl phosphate or potassium acetyl phosphate in formulation. Those are also anionic surfactants, but that cetyl group that is usually too long to provide much foaming. Usually, we're working with uh, C12, which is laurel, or things derived from natural sources like coconut or palm kernel oil. That have a lot of that C12 chain length, and those usually tend to be the best foaming surfactants. Um, so on the other side of anionic, we have cationic surfactants, and those are the ones with positive charges. Cationic surfactants tend to be very substantive uh, in personal care to both skin and hair. And so, quite often, the cationic surfactants are functioning as conditioning aids. And here again, we're usually trying to get as big of a fatty group or chain lengths onto them to provide good lubricity at the surface. And so that's where your um, phenyl trimonium chloride, BTAC or BTMS, steroconium chloride, those all kind of come in there. Um, and you can have surfactants that combine those two charges together, and those are typically called amphoteric surfactants. And that'll be things like cocometapropyl betaine, or cocometapropyl hydroxysultane, and there's others as well, but those are a couple of the most common amphoacetates. Like disodium cocoa amphodiacetate is very common as well. And so these products, yeah, they do contain the two different charges, and that allows them to have some fairly unique properties in formulation, especially when it comes to their interaction with anionic surfactants. And typically, the net effect is to improve the viscosity building of anionic surfactants, as well as to shrink the bubble size and make foam more stable in formulation. Then finally, the fourth group is non-ionic surfactants, and non meaning no, and so these have no charge. And so typically, you'll find these to be your kind of workhorse emulsifiers in formulation. They're also used a lot in cleansers to improve viscosity building as well. They reduce the amount of salt that it takes to get to target viscosity. Um, Solubilization is really just a subset of emulsification. You're really just making a oil droplet size that's so small that it doesn't diffract the light, and so this solution appears clear. And so usually solubilizers are also non-ionics. That's it, four types.
And so, to the few people that joined in just now, just so you know, there's a webinar chat. Feel free to chat in the webinar. You'll be able to see this webinar to the side. Feel free to chat in the webinar chat, is what I meant to say. And you'll be able to see the webinar to the side. So, if you have any questions, feel free to ask them there. My next question is around the structure, because I think that kind of paints a picture for how surfactants work. So they have a polar head or a water soluble head and a fat soluble
Right.
tail. So how does that structure allow surfactants to do what they do?
Yeah, so a lot of times it's called like the tadpole structure, because you can imagine, a tadpole with its kind of fat, like head and body, and then long, tail coming out from behind it. And for most surfactants, the head is the water soluble portion. Uh, this is typically the group of the molecule that's a carboxylate, or the sulfonates, sulfates, and that part likes to be in the water an awful lot. And then behind it, that tail is the long carbon chain portion, uh, anywhere typically from C8 carbon all the way out to C22, uh, depending on the desired properties of the surfactant. And that portion of the molecule is more like an oil. It's usually derived from oils, although that portion can be synthetic in some cases as well. But that part, because it likes to be in the oil, uh, and if you just put this surfactant into water, uh, that part of the molecule is going to want to get out of the water. It doesn't like being in the water. Uh, so if you can imagine, you're starting to put some of this surfactant into the water. All these head parts are going into the water. They like to be in there. Tails are coming out, all at the surface, and then eventually that surface of the liquid is going to crowd in too much. You can't fit any more of these molecules in. And then so what happens is the, these molecules start to aggregate, um, in a way, if you can imagine, kind of like a big ball, uh, where all those head groups, the water soluble parts, are facing out, kind of on the surface of the ball, touching the water. Then all those tail groups face inwards, in towards the center of the ball, and so the head groups kind of create a water soluble like outer layer, and then inside you have all the oil loving portions. Um, and again, is why they're so good at doing things like cleansing and emulsifying, is because all those oil parts that are stuck inside the middle of the ball can now incorporate other oils or dirts or sebum or what have you to basically emulsify or keep soluble those dirts and oils in the solution. And either you're rinsing them away in the case of the dirt and sebum, or you're kind of keeping it in a structure in the case of like an emulsion.
And so the structure that Dennis was talking about is called a micelle. And so for
Mhm.
emulsions, you've got like little oil droplets in those little micelles. And then for cleansing, the micelles help remove the grime from your skin. Now, how does the
Right, right.
structure, when we're talking about like how long the fatty or fat soluble portion of the molecule and then the water soluble portion,
Mhm.
so obviously it's different from surfactant to surfactant. Some have longer fatty acid chains and some have shorter.
Right.
So how does that chain length, or maybe HLB, what is HLB? How does that impact the kind of formulations you
Right.
can make?
Right. Yeah. So yeah, there's a couple kind of important things there in terms of the micelle and the structure of the surfactant. So um, the relative size of those, the head group and the tail groups are very important. And then kind of the absolute size of those groups is also, relevant to formulation. Um, Typically, you get kind of like a bell distribution, or if you imagine starting low, coming up high, and then coming back down again, of different performance attributes um, in the surfactant. And so, especially with regards to the that chain length of the tail. So for foam, um, the very short tails are very low foam, and then you start to increase again. And like I mentioned before, that C12 is kind of a sweet spot for a lot of surfactants in terms of maximizing the amount of foam. And then it starts to drop back down again. Um, for effects like detergency, your ability to remove the oils, now you're looking for a chain length that's most similar to the oil. And so um, you're, that's shifted usually a little bit towards longer chain lengths. And so the optimum chain length for removing oil is more like um, C14, C16, even C18. Um, and so you're really trying to balance, all these different properties in in your surfactant selection, and also why it's so useful to use things like the coconut or palm kernel oils, because they represent a distribution of those chain lengths, primarily centered around C12, but then also including that 14, 16, and 18 as well. Um, when we're talking about emulsification, again, we're trying to find emulsifiers that have a fatty chain that's similar to the oil that we're emulsifying. And so again, the longer, 16, 18 fatty groups are typically ideal for that. Um, Although again, it really makes a lot of difference in terms of the relative sizes of that head group and the tail. And so by um, changing the size of the head group, then you can achieve other effects, and that changes, how overall soluble this surfactant is going to be into water. One of the main ways that we do that, or have done that traditionally, is with ethoxylation, by basically extending the water soluble portion of the molecule. Now, that ethoxylation, we know that's I guess a little bit less desirable in the industry today, and so now we're starting to see newer technologies with newer ways of approaching that. But the net effect is the same um, by increasing, the size of the loving portion. We can kind of tune in the emulsification properties that we're looking for. HLB that you mentioned is the hydrophilic or water loving and lipophilic or oil loving balance of the molecule. It was developed as a concept. It was like ICI Industries, many years ago, 40s and 50s, to start to kind of predict how well a surfactant would be able to emulsify any given um, oil. And so the system was designed around non-ionic surfactants. It was really designed to characterize those surfactants. And so the system kind of tends to fall apart a little bit when we're talking about these charged surfactants or unusual, water or hydrophilic moieties. And so there's kind of a newer system that's starting to gain traction, less in personal care, but it's used a lot in oil recovery and in the household markets, and that's called the HLD system. D is in dog, and that's the hydrophilic lipophilic difference, and there's a whole different set of concepts associated with that system. But um, yeah, we are starting to see some people in personal care examining and seeing how it could be useful as a maybe a more robust tool to characterize surfactants and predict their emulsification properties.
So this next question is from Julia Ruby, and just so everyone knows, just in case there are more people in the audience wanting to ask questions, go over to Webinar Chat, the new channel that you'll see in the channel section, and you can ask your question. So from Julia, in a 2017 article on the topic of blackheads and sebaceous filament, formulator Stefan Co. specifically mentions two surfactants, disodium lauryl sulfosetonate and decylglucoside. From a
Mhm.
consumer perspective, do you think there's any merit in consumers seeking out cleansing products with these or other specific surfactants if they want to reduce the appearance of clogged pores? And then from a formulation, maybe I'll say the whole question and then I'll maybe repeat the first part of the question. So then we can, I'd imagine it would be hard to remember the full question. But, and from a
Mhm.
formulation perspective, how important do you think it is for a formulator to choose the right surfactants when developing a product to target the appearance of clogged pores? Are there certain surfactants you would recommend for this purpose? So the first part of the question is, do you think consumers should be seeking out specific surfactants if they want to reduce the appearance of clogged pores?
It's an interesting concept, and I'm actually I'll have to plead ignorance on kind of what the background was and how he isolated those particular surfactants. I mean, both of those um, are relatively mild surfactants. The sulfosuccinate is an anionic surfactant. The glucoside is a non-ionic surfactant. Um, you know, I think if you examine what the clogged pore is specifically, typically it's you have some of the keratin, at the surface. Those dry hardened skin cells. They typically slough off. Either get rubbed off or get rinsed away, uh, washed away when you're cleansing. Um, but sometimes an oil gland. Um, will be fairly active producing sebum, and some of those skin cells, instead of getting sloughed off, will agglomerate and get trapped inside that pore where the sebum is normally being excreted to the surface. And then you start to build that up, and that becomes the that oil or sebum starts to harden, and then you can start to trap anaerobic bacteria below the surface, and then you start to get acne and things like that. So um, I guess if I were to try to conceptually imagine what surfactant would be best at removing a clogged pore, I would think that it would be one that would have a good effect of um, breaking up that sebum clog, and be more like the sebum itself. And I think I would maybe select the surfactant with a longer alkyl group or chain length than the lauryl sulfosuccinate or the decyl glucoside. But again, it's hard to argue, actual experimental or practical data. So again, I think I'd like to see kind of what his approach was, and how he came to that conclusion.
So I guess you kind of answered the second part of the question about certain surfactants you would recommend for this purpose.
Right.
There's a little
Hmm.
bit of uncertainty there, but maybe
Right.
a question would be like, how do formulators decide which kind of surfactants they're going to include? And maybe this is a broad question,
That's an
obviously,
interesting one for sure.
because like obviously
Yeah.
like there's
Yeah.
many different products
This
out
is one
there,
of
and
the
it's
most right. Yeah. Yeah, it's probably one of the most prescient questions, right? I mean, there's certainly, I mean, we sell, hundreds of, surfactants, into a variety of different markets. And so, to the formulator, this seems like a rather daunting task to try to, select, a small handful to use in formulation. Um, usually, for personal care cleanser, you're trying to balance, some, specific attributes. A lot of times you're looking for high foam, something that will interact well with other surfactants to give good viscosity. People often look for that honey or slightly thicker appearance, and you also want to be able to clean skin or hair, but you don't want to often, clean too much. That just that Goldilocks zone, so to speak, of the just right amount of a cleansing, so that your face doesn't feel too dry, your hair doesn't feel too stripped after you wash, and then certainly you don't want something that's going to be too harsh or irritating. To either surface. And so it's a lot of different properties to balance, but the manufacturers of those surfactants are usually um, eager to help you to select and kind of figure out where to start at least. What I see a lot is that a formulator will say, "Well, I like kind of like the marketing concept of this surfactant. I like how this one foams. I like how this one is going to add some, unique or properties to my formulation." They just start kind of combining um, all those surfactants together, and then they'll come to me and it's like, well, how do I build viscosity, or how do I, attune, this or that other, thing in this system, and it's kind of a difficult way to approach formulation. And these surfactants, as I had mentioned, do interact in very specific ways. And so, the ratio and relative ratio of the surfactants is very important. to get to a system that's going to be able to deliver the properties that the formulator is looking for. Um, it's easy to use too much of one thing or another, and then when you go to add a fragrance, the whole thing comes crashing down, and it's thought you had something that was a good viscosity, but now it's water thin, and what do you do? And so we try to work with our customers to kind of navigate through that. Um, you really can't just pick off the shelf, three surfactants, combine them at the ratios, at random, and expect that you're going to hit all the aesthetic and performance attributes.
And mostly what we were just talking about is for cleansing products, but also obviously this is very important for other types of products out there. So,
Mhm.
for example, for lotions, I think it's interesting, and maybe a lot of consumers don't realize the importance of the emulsifier choice that a formulator makes in whether or not consumers will actually like the product. For example, the feel. Much of the aesthetics of a end product are determined by the emulsifier choice as well as the emollients. Would you like to
Mhm.
add to that?
Yeah, I mean the emollient effect definitely is going to be driven again by that the fatty or long chain group, and the longer you can get that, the better it's going to feel on the skin, because then it's more lubricious, because you have that kind of a big oil loving domain that's going to provide some slip or soft feel to the skin. Um, but again, you're usually sacrificing some other property in the formulation when you incorporate that. You can kind of tune in a formulation so you have one ingredient that maybe has that property, but you have the other ingredients that are driving the other benefits in the formulation. Not sure if I exactly answered your question, but hopefully that was
Emulsifiers
interesting.
are important. The choices that you
Yeah,
make are
right,
important. Uh,
right, yeah, yeah. And I think yeah, getting again, yeah, to that emulsifier selection, and how do you pick the right one? Um, this is another one again that a lot of formulators will. Well, this sounds nice, but then when they start to just kind of drop in, whatever they're playing around with, that things can go astray fairly quickly, and kind of need guidance to retune. Um, it's very rare that you have a one size fits all for emulsion or emulsifiers. There are a lot of interesting products that are out there that really make things a whole lot easier. Um, some of these, polymeric emulsifiers are super great because they um, will emulsify a pretty wide variety of oils and esters, and they'll set up kind of a gel network to limit, the amount of coalescence or splitting, in the formulation. And a lot of people gravitate towards those, but I think we're starting to see a little bit less of that because people, again, going towards more naturally based formulations. These are, typically synthetic products that are able to deliver all these high performance attributes.
and then when we were talking about lotions, a lot of what we were talking about previous in this conversation was around oil in water emulsions,
Hmm.
but there's also water in all oil emulsions. I
Hmm.
said that right. And the choice of
Right,
emulsifiers will also be important to that. I don't know
right,
if there's
yeah.
anything
So
to add to
yeah,
that.
right. No, I mean it's just all the stuff that we talked about in terms of how the micelles accumulate, and all that is basically turned on its head or inverted in the water in oil emulsion. So, all those the head groups or the water loving groups will be oriented inwards, and the oil-loving portions will be oriented outwards. Um, there's what's called the Bancroft rule, and I think it's a tries to predict kind of the sort of emulsion or that you'll get, and it basically says that kind of the water solubility of your bulk emulsifier will dictate the sort of emulsion that it's going to be best suited for. So oil soluble emulsifiers are better suited for producing the water and oil emulsions.
Yeah, and I guess if you kind of think about what that looks like in a test tube versus like if you have a lot of water versus if you have a lot of oil and you're trying to get water droplets in the oil versus oil droplets in the water, then the
Right.
fatty portion will be faced outwards or inwards depending on um, what's the main solvent in the solution.
Right. That's not necessarily just the relative proportions. I think a lot of people assume that if they have like 80% water and 20% oil, then it's oil and water and vice versa. But you can actually do really interesting things with the right processing and surfactant selection. Things like high internal phase emulsions, where you can get um, over 80% oil to be in the internal phase. And they're really interesting, aesthetics when you do things like that.
So now I got a question in the chat from Sam Morel. Are alkyl phenyl ethoxylates used in many personal care products? If so, are they being formulated out due to EPA concerns of bioaccumulation?
Right. Yeah. So, yeah, I think the most commonly known or class of these is the nonylphenol ethoxylates, which are not typically used very much in personal care for exactly the reasons that Sam pointed out. They've been targeted for bioaccumulation concerns. Interestingly, um, and maybe timely, depending on we're watching this live or sometime in the future. We are still in the age of COVID. The octylphenol ethoxylates are used a lot as excipients in drug manufacturing and other things. So there's right now some efforts in Europe to have some temporary reprieve on some of the restrictions in the octylphenol ethoxylates to accommodate um, some of this, drug development, things like that.
There's
Yeah,
another
not usually good actors.
there's another question from Julia. Um, how much of a concern is skin irritation when formulating a hair conditioner?
Yeah, here there's a couple things at play. So the quaternary compounds in general, as a class, can be uh, quite irritating to skin and eyes. But on the other hand, when we're trying to formulate hair conditioners, we're usually, again, selecting alkyl groups that are very long chain length, and that is a huge mitigator for that irritation potential. And so things like the workhorse conditioning agents that we've already talked about, siraphonium chloride, um, ETMS, BTAC, those are all uh, typically very low irritation. And in a hair conditioner, it's unusual to really need more than 2% active of a quat to kind of deliver the desired performance. And so um, when looking at hair conditioner, it's pretty rare that the conditioning active, so to speak, is a big driver of irritation. Um, more often than not, it'll be things like the fragrance or other additives that are put into the conditioner.
Now, why are cationic surfactants often more conditioning, and why are negative surfactants often more cleansing?
Right. So the cationic portion of those surfactants is positively charged. Uh, both skin and hair tend to have a net negative charge at the surface due to um, fatty acid residues at both surfaces. And so uh, the positive charge of that conditioner likes to be connected to the opposite negative charge on the skin and hair, and then you get that substantivity. It sticks to those surfaces. Anionic surfactants, of course, the opposite, not very substantive to those types of surfaces, and again, very good at usually by design at removing dirts and oils.
Um, and then we have another question. I've heard reference to poloxamers as uniquely equipped to cleanse the skin while maintaining, reinforcing the integrity of the skin. Are
Uh-huh.
there properties, if any, that are unique to this sort of surfactant that would correspond to any such benefits?
Um, well, I mean, there's certainly incredibly low irritation. So, plaxamers are a class of non-ionic surfactants, ethoxylates, um, that typically offer, um, you know, fairly good, foaming with incredibly low irritation because they're fairly high molecular weight. So, high ethoxylates of the fatty alcohols and things like that they're starting with. They can attenuate the foam by introducing, instead of ethylene oxide, the propylene oxide. That causes some defoaming effect of those. And so you can kind of tune in again exactly what you're trying to do. Um, they're used a lot in oral care because they're so benign. But as far as restoring properties, I'm not. I guess I wasn't aware of anything that said that they were good at reinforcing or restoring skin barriers.
Now, a question that I've got asked, and I never really looked into this. Um, there's an idea that emulsifiers can be irritating because they can emulsify the oils on your skin. What's
Mhm.
going on with that? And should consumers be
Right.
concerned? And also, as a
Yeah.
formulator, are there specific decisions we should be making so as that's not a
Right.
problem?
Mhm. Yeah. No. I think you could maybe kind of look at it. Yeah, a couple ways. Yeah, the emulsifiers, because they do such a good job at emulsifying natural oils, and a lot of natural oils contain um, fatty acid groups that are very similar to the fatty acids that are part of the intracellular matrix of the skin. That glue that binds the skin cells together. There has been an ongoing concern that the emulsifiers or surfactants used to form emulsions can disrupt the skin barrier and cause increased penetration into the skin. Now, you ask some formulators, and they'll say, "Well, that sounds like a fantastic idea because I have my quote unquote active ingredient that I want to penetrate into the skin and have some effect on the skin." Um, and so I think the risk again of irritation has a lot more to do with what some of those other ingredients are that are in the mix. Um, you know, Usually emulsifiers as a class are relatively benign in terms of irritation potential by themselves. Um, but you start incorporating some other ingredients into the formulation, and definitely start to increase irritation from those products as a class.
And to me, it seems like for most products, well formulated products, any risks would be outweighed by the benefits because long term, we know that like things like lotions will reduce
Mhm.
transepidermal water loss and help with
Right.
moisturization and stuff. And that's a good thing for maintaining a healthy
Yeah, yeah.
barrier.
I mean, yeah. I mean, like to your point, we measure, kind of how much. Uh, One of the best ways to measure, the I guess moisturization potential of a product is how much water is being lost through the surface of the skin, because it's slow to get up to the surface through the epidermis, and if you're quick to lose it, then you start to run into issues, and so um, we know that a well-formulated lotion is going to reduce that amount of water that's being lost through the surface. And so if there was damage, if there was bad uh, functional damage to the intercellular matrix, that would increase transepidermal water loss. And sometimes that increase in the water loss or tool is used as a way to quantify the damage produced by surfactants and cleansers. And so we know that if we are doing the wrong thing, that it is measurable, and we know if we're doing the right thing, it's also measurable.
And now I asked this question to you on a podcast before, but how will the latest regulations in New York have they come into place? Wasn't it supposed to be 2020? I forget. The New York bill for
Right.
one for
Yeah.
dioxane. So how is that going
It's
to
the end of
impact?
next year. Yeah.
Did it change or was it always that
Yeah.
everything's
It was
a
always. Yeah.
blur?
Yeah.
The
Yeah.
last 6 years. Um, so maybe 4 years would be more accurate. So how will this impact the surfactant industry? How will this impact the products on the market? Will consumers notice this? Will this
Mhm.
impact? You had brought up some of the potential sustainability impacts of this, and also,
Mhm.
is there like good evidence to support a need to reduce 1,4-dioxane in surfactants in the way that the bill is proposing? This will, I'm assuming,
Right.
this is a very leading question, impact the
Yeah.
global market. But what do you think?
Oh gosh. Ah. So yeah. I mean, yeah. Ethoxylation uh, as a chemical process can produce a variety of byproducts. One of which is 1,4-dioxane, which is a potential carcinogen. Um, typically the amount of that byproduct is very low. There's been a lot of safety assessments done over the years, not just in the United States through FDA, but also EPA, and then worldwide, Europe and Asia. And I think the general consensus is that products as currently formulated uh, don't really present a significant risk. Uh, to thoroughly mitigate that risk, a lot of these regulatory bodies are starting to suggest that personal care products should be limited in the amount of dioxane to about 10 ppm, seems to be a general consensus. Um, the New York state law was driven in large part by the presence of 1,4-dioxane in groundwater, especially in the New York City area, the Long Island Sound, and that dioxane was due primarily to improper industrial practices that contaminated those waterways. with very significant amounts of dioxane. Dioxane by itself is used as a disinfectant in some areas, and so it is sometimes handled just as a pure substance, not just as the byproduct of the ethoxylation. So um, New York State has put very aggressive limits on the amount of dioxane in a variety of consumer products, including personal care and house care, uh, and also like leave-on skincare products as well. And they've set forth those limits, and there's basically a stepwise reduction. But at the end of 2021, the first step for personal care takes dioxane all the way down to 2 parts per million, which is incredibly low. Um, in order to comply with that limit, uh, formulators are really kind of looking at the formulas of what's in them. The biggest source of dioxane typically in a personal care product or personal care cleanser is through the alkyl ether sulfates. And that's because as part of the processing for those ingredients, um, some of the alcohol ethoxylates that are used to make them can actually generate additional dioxane beyond what's in the original alcohol ethoxylate to start. And so it's not unusual to have an ether sulfate produced by your run-of-the-mill um, surfactant manufacturer that could have as much as you know uh, 30, 50, even 100 parts per million dioxane. So you can see that if your limit in the formulated product is 2, and that's where you're starting, at up to 100, it's not a good position to be in. So the manufacturers of these surfactants do have uh, um, processing capabilities to further reduce the dioxane, and many of those have implemented those. I guess they're basically reactor add-ons that post-process and remove the excess. And so a number of manufacturers can now deliver ether sulfates with less than 10 ppm. And there is another manufacturer that can actually go to less than 5 ppm dioxane in their highly concentrated ether sulfates. And so that gets you into a space that you can uh, continue to work with those chemicals kind of as a class. One of the biggest things that I was concerned about with the legislation was really directed towards the home care market, where a lot of alcohol ethoxylates are used at fairly high concentrations. Now, again, because they're not typically the ether sulfates, their inherent levels tend to be fairly low. 10 ppm or less already is pretty much a standard for the alcohol ethoxylates that are used in home care. Um, but again, with the limits set forth by New York State, it's going to be very hard to comply, and it's going to be very challenging to produce these kind of highly concentrated household products. So in order to get that literal, 4x or 8x concentration of surfactants, you really have to go to this class of surfactants to do that. Now, there's um, people approaching this from different directions and looking at dry surfactants that are non-ethoxylated and producing either slurries or powder products or solid tablet products to try to circumvent some of this. But if you look at your major brands that are doing, concentrated um, home cleansing products, usually they're going to be higher than that 2 ppm or 1 ppm, which is the eventual limit. So Home Consumer Product Association, Household Consumer Product Association in the U.S. has been lobbying New York State to try to get some relief and better guidance and on the legislation. Try to again reinforce the fact that at the levels that these things are in the products, they pose very low risk. If you look at groundwaters elsewhere throughout the country, they're nowhere near the levels of dioxin that are in the New York City, Long Island Sound area. So this is a situation that's unique to New York and not caused by personal care and home cleaning products.
And if anyone watching wants a whole bunch more details on this topic, I had Nicholas Georges on my podcast from HCPC. Is that the acronym?
HCPA, I think. Home
HCPA.
Consumer Products, Household Consumer Products Association. Yeah,
From
I think that's it.
that organization, him, Nicholas Georges. So if you want a whole
Yeah.
bunch more from him, and we also talked about some of the new legislation coming in California, then go listen to that podcast. Now we've been talking
Yeah, there's
for. Oh, sorry.
new labeling rules. Yeah, I was just going to say that, are going to, I guess, basically put household products more in line with personal care products in terms of label transparency. So that's some of those things are a good thing, but the industry kind of wants to make sure that they're at the table when these rules come into play.
Now, we've been talking for 53 minutes. Thank you for being so generous with your time for this webinar. I guess my final question to you would be, do you have any final take-homes about this conversation? Any points that we've missed about surfactants that you want to leave the viewers with?
Yeah, I think, again, surfactant selection is super important. The interaction between surfactants is sometimes a bit of a black box to formulators, and definitely there's a lot of stuff going on there. Um, Making sure that you're kind of dialing in all those different product attributes that you want to be able to deliver in terms of the consumer uh, experience. And so I can say that we're all here to help you. Most surfactant manufacturers have a deep library of starter formulations, and it's really important to kind of um, pay attention to those when starting to make sure that you're getting the right balance of attributes. Um, can definitely help you to make changes and customize and deliver other things. But unless you've got a fairly deep experience, um, it's really difficult to just try to throw some things together and expect them to do what you want them to do.
So I hope everyone enjoyed this webinar. I hope you found this helpful. I certainly did. That was very informational. Thank you, Dennis, for agreeing to be the first webinar speaker, especially because we didn't
Yeah.
really know what we were doing for this first one. But
Right.
this was pretty easy. So I'd like to do this again. For those watching, if you have any topics that you'd like to see us cover in a future webinar, again, I'd like to do this once a month from here on in, and I'll probably feature experts that are already in the Discord community. So if you have any topics you'd like to see covered, then let me know in the webinar chat. I hope you all have a great rest of your day, and thanks again to Dennis.